Hi, it's teardown time again. We've got another bit of Rohde and Schwarz power supply kit, and we love looking at these things. I've had this one for quite a while. I was going to do a video when it was released back in April, but unfortunately things got in the way. And we have seen the NGA100 teardown before. I'll link that in up here if you haven't seen it. And it is a cute little smallish form factor, triple output, 33 watt per channel power supply, and this is part of their basic series power supplies. But they've released this new NGA100 series. It's not designed to replace this, it's designed to supplement it, and it's a bit of a different beast. It either comes in a single or a dual output. There's no triple output version of this. Now, it's advertised as a linear power supply. Whether or not it's a linear output stage like this with a switch-in tracking pre-regulator, that remains to be seen. But it is significantly bigger. Check that out. It is much deeper for actually less output. This is only 40 watts per channel, so 80 watts total. So technically, this is less total power output than this series up here. So it could be completely linear. There's a reason for the size in these suckers. Anyway, exactly the same look and feel form factor. These actually fit in a 19-inch rack mount, so you can actually get a rack mount kit to mount like two of them side by side in a 19-inch rack, so that's very nice. But they do come with the tilt-in bail feet on them. And even though it's part of the basic series supplies, here's where it fits into the overall scheme of things. It's, got some pretty advanced stuff in terms of like low current measurement and resolution and accuracy. It's like 0.02%. It's absolutely crazy, and you'll get 1 microamp current resolution out of this thing. So I'm really looking forward to powering this thing up and having a play around with that. Anyway, we'll do that at the end because you know what we say here on the EEVblog, don't turn it on, take it apart. But it comes in two different models. The one we're looking at, this is the NGA102. This is a 2-output, 0 to 100 volts per channel. So this is rather novel. There's not many power supplies that'll do 0 to 100 volts. And this will do 0 to 100 volts at 2 amps per channel. And of course, you can put them in series to do 0 to 200 volts at 2 amps, or you can put them in parallel to do 0 to 100 volts at 4 amps. The other model, the NGA102, that is the 35 volt supply, and that'll do up to 6 amps. And as you can see, they use the same terminals that they used on the NGE series up here. I'm not a fan of these. They don't open very wide. If you have a look there, it's really difficult to get. There is a hole down through the thread in there. You can get your wire, but I really don't. I'm not a fan of these terminals. Look, you can't open them very wide. There's the hole. Maybe you can see it down in there. And I don't know. And they're red and blue. That's that European rubbish color code. So, I don't know. I prefer red and black. Call me old-fashioned. And thanks to Rohde and Schwarz, I actually have 2 of these to give away. I've got one 142 model, the 0 to 100 volts, and one 102 model, the 2-channel 0 to 35 volt model. So stick around for the end of the video for details on that giveaway. Everyone loves a giveaway. Now on the back, which we didn't get on the NGE model, we've got the sense inputs as well. Rear channel sense on the back. That's really nice for doing remote sensing on loads and stuff like that. So even though it's a basic series, they've added that. Fantastic. And then we've got digital I/O trigger as well. Really great for production, automated production test systems, which I've done a lot of in my career. Anyway, it's got the LANs and the USBs, and there's a Wi-Fi option as well. Oh, look at the big bolt for the toroidal transformer. Oh, everyone's getting a bit moist now. And interestingly, they've got the voltage selection on the bottom here. Good old-fashioned switches. Nice. I like it. Warranty expires if broken. Not one stuff given. All right, so let's get this bad boy open. And even though this is the basic series, don't get excited that you're going to be able to get a Rohde and Schwarz power supply for a couple of $100. This is still an advanced bit of kit. And it's, I think, price, like retail price is still like 1,500 Yankee bucks or something. So it's not cheap, but Rohde and Schwarz don't make cheap bits of kit. That's why it's going to be really nice inside. So, can we lift this off? Whoa, we're in. Oh, look at that. Beautiful. Oh, very different. Very different to the NGE series, which was a real compact beast. This one actually has a fair bit of space inside, and obviously it looks like it's a full linear jobby, because look at the size of these power supplies, whereas the NGE series, that was a linear output stage. Here's a photo inside that with a little itty-bitty tiny output heatsink on the series pass linear element on the output, but then it had a tracking pre-regulator which pre-regulates like just like a volt above the output or something like that. So you don't need much output heatsinking, but yep, sure enough, this bad boy looks completely linear. And that toroidal transformer, oh, absolutely brilliant. And one complaint I had about the previous one is that if you short out that bolt there, then of course you can get a shorted turn on the thing. So if that's a trap for young players. So if that's actually too close to the top case, then you're going to come a gutser. But this one, nah, that feels like it's got a whole finger width in there, so no worries. Oh, you can see you're getting your money's worth inside this, and all the output is sleeved. Look at, oh, it feels, it's not feeler vision. Beautiful sleeving on that. And of course, all the processing's on the front. We're not too fussed about the processing. There is the Wi-Fi option. I think that's like I don't think it comes standard, don't quote me. But yeah, it might be like a software option, but there it is. So I'm not too fussed. There's an Atmel something or other processor down in there for those playing along at home. Not too fussed, but yeah, that's the complete controller board down in there. Got the battery backup for the real-time clock. It'll have really advanced ADCs on it, because as I said, we're talking about 0.02% accuracy. We're talking about 1 microamp current resolution on the 200 milliamp range. So, you know, as we'll see when we power this up, it's got lots of digits for current measurement. So if you're a current measurement fanboy, ooh, this is going to be a really nice option for you for measuring like low power devices. And there's our output board down in there. Nippon Chemicon, of course. When you pay this sort of money for a power supply, even their basic series uses Nippon Chemicon caps. Absolutely very nice. So we've only got 22 microfarads output cap, plus I think I see some ceramic surface mount jobbies on the back there as well, but I won't take that out. But yeah, as with all lab power supplies, you want to minimize the amount of output capacitance, because when you switch from constant current to constant voltage mode and vice versa, you don't want the energy in these capacitors, because these are after the current regulation circuitry. So you don't want a huge amount of output capacitance, because then that can dump current into your load above your current setting. So yeah, so that's good. 22 mic plus whatever, you know, a 10 mic ceramic or something on the back, or 1 mic or something like that. So nice low output capacitance, very nice. And this supply has supposedly really fast transients as well, so fantastic for all sorts of production testing. Oh, check out those beasts. Look at them, 6800 mic a pop, 80 volts, Nichicons. So they must, 80 volts, it's got 100 volt output. So I assume that they're in series, are they? Let me just adjust the exposure here, because those heat sinks really can cause the camera to underexpose for the rest of it. So yeah, so we've got 2 banks of these. You might be wondering why we've got 3 heat sinks here when we've only got a 2-channel regulator. Well, one of them, if you have a look down there, is for the bridge rectifier. So yeah, just one alone for the bridge rectifier. And we've got a fan on the back. Of course, the heat sinks are all finned correctly to get the airflow through here. So we've got the vents on the side at the front here, so the air's drawn in here and then goes over the fins of the heatsink and extracted out the back there. So not a particularly large fan. It is temperature controlled, because when you turn it on, it does go and then it eventually switches off, and only if you do high loads will that come on. Nice attention to detail with this little heatsink down here. They've just got some, well, that's actually, oh, that's really hard it's not really Celastic, it's something else. Anyway, they're rigidly mounting on those, so any vibration on the board won't cause these things to flap around in the breeze and vibrate loose and hit a resonant point and break off. Very nice. It looks like the code name for this project is Stingray. It's the Stingray motherboard. There you go. There's our mains input down there, beautifully crimped and screwed down to the chassis there. And that is an Ethernet cable going from the Ethernet port on the back through to the Ethernet connector on the front panel board. I don't know what times 1600 means, and this has times 1601. So I'm not sure what that's for. Bueller. So our mains cable is heat shrunk like that, and that goes over to, here's our input down here. There's our common mode choke and our protection and our X and Y class filtering. So that's very nice. Can I get the rest of that out? And there's our main switch, real clunking main switch on the front. Nice. And I assume that this tap on the transformer here with this little power supply part, that's probably just for powering the front panel digital board, I'd say. And there's our voltage selection main switches down on the bottom of the case. I like how this is just all one big single board construction. Of course, you've got to have the front panel separate because that's a totally different technology and it's isolated. And by totally different technology, I mean much higher layer count, everything else for the BGA packages and all the digital whatnots. But this one down here, just one big analog jobby. Now, I can't read this detail on the screen here, but that looks like most of the control stuff for one of the channels. It's duplicated on the other side, so we don't need to see the other side there. So, yeah, it looks like we've got two shunt resistors here. They look like a couple of MOSFETs, are they? Yep, so they'd be doing your current range switching. And is that your ADC down there? Not entirely sure. If we move over to here, this is the input, of course, coming from our transformer tap here. We've got some input surface mount fusing down there, but that's not designed for protecting your output, of course. That only pops in case of circuit failure. Now, in terms of the output here, of course, they're going to have the current sense there. You can see the extra sense wire on, so the main drive and then the main, and then sense wire coming back for the positive and negative. They snake all the way along the back of the case over to a relay over here. So that relay there, that could be for doing your series parallel stuff. So I'd say that's the case there. And of course, that's right near our output sense connections as well. Not sure what's happening down in there. Hard to get the light at the right angle to see a part number on that jobby. Once again, can't read that part number from my camcorder screen, but something's going on there, which is interesting. That's smack in the middle of the design, so it's like shared both, but we've got jumper settings there, once again with the X designator, so not sure what setting that's got. Here's our bridge rectifier. There's actually another one next to it. It's hard to see in there, but it's a smaller one, and that's duplicated on the other side as well. So this one heatsink handles 4 bridge rectifiers. So one would be the main power bridge rectifier, another one would be a secondary one for powering something else, like the control stuff. And there is our main output MOSFETs with a nice looking temperature sensor on the heatsink there. That's very schmick, of course. Any decent power supply, especially in this sort of price class, even though it's a basic, in quote marks, model. Yep, nice. This thing would be bulletproof. So there you have it. That's a teardown inside this bad boy, and very impressive, of course. Very high quality construction, high quality components used, and it'd be lots of precision parts as well. As I said, we're talking about 0.02% class accuracy with, it'd have a really high resolution ADC in this thing, and current range switching and stuff like that. Let's actually put this thing back together, power it up, and I'll show you the resolution on this, which is really quite remarkable for like their bottom of the range instrument. Okay, so let's turn it on, and as with the NGE series, you turned on. Don't know if you can probably hear that, but trust me, that is really loud. I don't know why they have to default to like maximum turn on for the fan. It's really annoying. I know the processor's not booted up yet, so the fan just defaults to you know, 100% on, but if there was some way that they could fix that, that'd be really nice. Anyway, straight off the bat, everyone's soiling their pants. Look at the resolution on that current. We're talking 6-digit resolution. This is incredible. That's 10 microamps there on like the full 2 amp range. So let's change the current here. Sure enough, oh no, okay. So the set current, we can only go to 1 milliamp. Yeah, I believe I read that in the manual somewhere. That's all right. But the readback current, I assume, unless these 2 digits on the end are fake, then yeah, we should be able to read 10 microamps resolution on the 2 amp range. That'd be incredible. That's amazing dynamic range. You know, if you're developing like a Wi-Fi product or something like that, you can like just keep it on the 2 amp measurement range and measure, you know, like an amp when it's transmitted, or, you know, you got some high-powered product doing something like transmitting a decent amount of RF or whatnot, and then you, and then when it goes to sleep, or just, you know, background idle or whatever, and it's drawing, you know, 100 microamps or something, you can still get decent resolution on that. Nice. Yeah, so the minimum we can go there for our constant current mode is 1 milliamp, but of course that's like plenty. So let's just switch that output on, right? So we set it to 20 volts. Well, look, I can show you that it can actually go much higher than that. There you go, 100.05 volts maximum. Not too many power supplies on the market can do you know, 0 to 100 volts. As I said, this is the 142 model. The 102 model actually has 35 volts maximum output, I believe. You know, your more traditional voltage range power supply. But with that, of course, you get extra current. You get 6 amps instead of 2 amps maximum. So the key layout's all the same. The operation is the same as the previous one, except, of course, the display is significantly different to the previous one. As you can see, the display is significantly different. This new NGA one actually has a lot more information. It's got your Pmin and Pmax here, and of course your Vmin and Vmax. And of course it's only dual output, and that's why I guess it can display more, but this one could have displayed the same sort of info. So they do have a new, like they've got a B model of this or something, I believe now. I'm not sure what the differences are, but yeah, because this one's been out for quite some time. But yeah, that is a nice display. Not as big. I guess it would be nice if it had like options to like make the display a bit bigger or something like that, like the font's a bit bigger, and maybe if you didn't need this other stuff, you could have like a bigger display like up here or something like that. But as I said, this has got more digities, more goodness. But look at the resolution difference. I mean, this is only like 3 digits for the voltage, 4 digits resolution for the current. This is 6 digits for the voltage and 6 digits for the current. You know, no contest. But of course, there's a reason why both of these models exist. Like this one, it might be more suitable for some tasks, and this one's more suitable for other tasks. So it's not like this one is just better in every respect than this one here. It's, you know, pros and cons. Go and read the data sheet for yourself. I mean, this is triple output for starters, smaller form factor. You know, it's significantly different. So let's switch on our output here and see if we do get the extra 2 digits measurement resolution there. So let's see if we go down to 10 microamps, and we do. Yep, that's incrementing by single digits there. Like, so we're down in the noise. Like, so it's, you know, even though we've got no load on this thing, can we actually zero that out? I'm not sure if they have the ability to do that. That'd be nice, wouldn't it? Given that, you know, they advertise the capability of this thing to measure like down to 1 microamp. So apparently there is a 200 milliamp range we can switch to, and we get an extra digit yet again. Now this is interesting though. Like, it's given us like Vmin 16.5 volts here. So is that like what it's actually measured? Minimum? Like, that doesn't seem to... Is that changing? No, 16.5 volts minimum. That doesn't make sense. And 3.77 watts maximum. I've got this set to 100 milliamps. It would have been nice to put the display here and show what our current limit is. With, you know, I've set that. There it is there. I've set it to 100 milliamps current limit, but they don't actually display that, which with all the information on the screen, like, why not? Yeah, I don't get this at all. Look, I've been playing around with this, and look, I've got no load on here, and it's showing me like P max equals 0.36 watts. Where did it get that from? And as you saw before, it was like 16 volts from 100 volts. What was it measuring that minimum when it was ramping down, when I actually switched the output off like that, on and off? If I just, I don't know, keep doing that a number of times, is it like glitching or something, or, you know, taking the measurement at the inappropriate time when it's, but how it does that for like current, I don't know, like I maximum, like 21 milliamps, or where's it drawing 21 milliamps? I've got no load. Don't get it. So anyway, yeah, these are Vmin, Vmax. These are operating like your digital multimeter min-max mode, and P min-max as well. So it's like historical data to show you, but I had a look at the menu and I can't see where it doesn't, it just mentions this. It doesn't tell you where to reset it or anything like that. I mean, you know, you go into menu and it's like, well, where do you reset that? I don't get it. So yeah, that's strange. I don't like, they've got all this min-max information here. Like there should be like a min-max enable button on the front panel. Really? I mean, electronic fuse button? Like, you know, that's, you could argue that should be like buried away in the menu, or remote, well, remote local, that's okay. A log button, of course. And yes, we do actually have the USB login, but we've got no stick. And if we plug in a stickity-doo-dah, is it going to just automatically log that? And it does 10 readings per second detect in USB. Oh, come on. What? Oh, I finally got a USB stick that works. Supports FAT32 only, but yeah, there we go. Login started. So presumably it logs all the voltage and current and everything else. I'll overlay what I've got here anyway. So even though I've got no load, but it should get something. Should log voltage and current for both channels continuously at 10 times per second. So that's really nice. Anyway, let's go into our menu here and have a look. Yeah, similar sort of thing. Output, protection, fuse, easy arb, easy ramp. There's some features for doing programmability. Current range, there it is, current range. So yeah, it's not automatic. We have to go in there and select that. Current range, there you go, current measure. You set it separately for each channel. So let's go low there. And boom, and get out of that. Boom, look at that. 1 microamp resolution. Thank you very much. And once again, we're just seeing the current noise floor here, basically. And ripple and noise here, over 20 megahertz bandwidth. We're only talking like 150 microvolts RMS. This is no load at 10 volts. Its spec for the 142 is less than 1.5 millivolts. So it's like an order of magnitude under that with no load. The 102 models actually are 500 microvolts ripple and noise RMS. And ripple and noise at 3.3 volts at 1.5 amps. I had to set my current range to auto, like the current resolution there to auto. You can actually set it and it jumps up. Otherwise, but yeah, you can come a gutser. Anyway, at 5 watts there, I've only got like a little in load on it, 12 millivolts peak to peak, but still well under spec at 750 microvolts. Anyway, this is not a review. I'm not going to go to town actually reviewing the performance specifications on this thing. I'm sure it meets every single one of them. You know, it's a Rohde & Schwarz. Okay, let's single shot capture this into a 2 ohm load, so 3.3 volts into a 2 ohm load with 2 amp current limit. We'll just switch that on and boom, that ramped up nicely. You can see it doing some, yeah, it looks like, is it doing some hunting in there? But as always, we're looking for overshoots there and there aren't any. So, yep, that is clean. Although, it's almost as if that is a deliberate ramp on. I wonder if there's like, that's part of the, no, that wouldn't be part of the easy ramp thing, would it? No, it's turned off. Anyway, that's only like 2 milliseconds there, so yeah, no worries. Doesn't overshoot, that's the main thing. All right, so what I'm going to do now is just test the transient with constant current. So I've lowered it to 1 amp here. So how quickly will it go into constant current mode? Will it detect that there's an overcurrent and will it go in? So let's set that up and boom, there you go. That's interesting. So there you go. You can see it ramp up like it did before. It went to its 3.3 volts. So it went to the output voltage. Then it took 5 milliseconds. It took like 8 milliseconds or something, 7, 8 milliseconds to realize that, I need to go into constant current mode. So it's overvolted on that. And there's a little, that's interesting, little blip in there before it realized, no, I need to go into constant current. Thank you very much. So is that a problem? Well, potentially. It depends on your application. So, Okay, for comparison, let's see how this new Keysight EDU triple output power supply does under exactly the same circumstances. 3.3 volts with 1 amp current limit into my 2 amp resistive load here. So let's give that a whirl and switch it on. I've got exactly the same time base as before. I don't think I've touched that. Lowered the trigger level down here, and there you go. That is significantly different, but that one doesn't overshoot in terms of voltage, does it? So once again, it's got an interesting characteristic response here that just so happens to be near the, that's just a coincidence, that it's near my trigger level here. Of course, if I increase my trigger level up above that, we can do that again. There you go. So yeah, that's got an interesting response there, but this one doesn't overvolt. So yeah, it's got a bloop bloop. Yeah, so the Rohde & Schwarz one is not that good in terms of its constant current at switch on capability. So I'm wondering if they can, tweak that in software or something, because yeah, that's a potential issue. You don't want your technically, because you're over voltage in there, you are also over currenting, because it's simple Ohm's law. Voltage, 3.3 volts into your 2 ohms is above your 2 amp, your 1 amp current limit, of course. So yeah, so you are over currenting here, whereas the Keysight one won't do that. And I'm sure if we measure a whole bunch of lab power supplies, they're all going to operate, they're all going to have their own characteristic response for something like that. But yeah, that's a bit disappointing that overshoots. It'd be interesting. Let me try the NGE series and see what happens on that. There you go, 3.3 volts, 1 amp. Let's give it a whirl, see what we get. There's our previous Keysight one, and single shot capture that. I've gone back to 5 milliseconds per division. Oh, there you go. Once again, see, significantly different response. 5 milliseconds per division. So it takes much longer, and it has a different kind there. Once again, it's ramping up. There is some overshoot, and it eventually comes back. Let's just run that again. And I've got positive edge triggered, so I can just switch it off and on. There you go. Once again, it's overshooting like that. So yeah, both of these Rohde & Schwarz supplies have a problem with constant current overshooting. No problems at all with constant voltage. Of course, when you switch that on, it's just hunky-dory. But yeah, that's something that they might want to look into. So I don't know if this would be a real-time software response loop doing that, or whether or not it's a an analog loop in the supplier. But anyway, I hope they can fix that, because that's certainly something to consider, because technically that is overcurrenting. Not by much, but yeah, both of them just do that. Interesting. Now check this out. What I'm going to do is I'm going to actually change this to 20 volts. I was just mucking around with it, and I discovered this. Okay, I've got the same 1 amp current limit, so you'd expect it to have the same result. We've seen some overshoot already in voltage, but on the 20 volt range, this didn't happen on like the lower voltage ranges, but 20 volts. Nothing else has changed. Okay, watch this. Ta-da! Look at that. It ramps up, and it goes up. Right, we're 10 milliseconds per division, so after like 6-7 milliseconds or something, it determines, oh, I need to current limit, right? So it's headed all the way to its 20 volts, and then it's come back down, and it's sort of, clipped it at 4 volts there, and then it goes, ooh, for another, 10 milliseconds, 11 milliseconds, then it goes, oops, nope, I'm still over voltage, I need to, current that down to limit the current. So that's interesting. But if we do that I'll go back to 3.3. Okay, so I'm back at 3.3. Let's single shot capture that again, and boom, we got it. Once again, it's clamped like that, but at a different voltage again now. So that's interesting. And if I go to 10 volts, let's try that again. single shot capture, output, and there you are. We can see it's sort of starting to do the thing there, but it then goes back down aggressively. So that really depends on the voltage range that we're actually got there. And another interesting thing, check this out, right? If we go into voltage, and I'm twiddling this, I'm still in constant current mode, but you'll actually see this go green. Whoop, you see? It goes green like that, and I'm not sure what the deal is there. So is it jumping out of constant current mode? Maybe we need like a live display. Okay, so I've got it in roll mode now, and we're in current limit down here. So let's see what happens if we change this voltage again. I just want to see if it jumps out of constant current mode. Oh yeah, look at that. Look at that. It's jumping out of constant current mode. That's interesting, isn't it? Wow, we should be able to single shot capture that actually. Let me get out of roll mode. All right, so let's see if we can capture this. I've got 10 milliseconds per division. Okay, I'll adjust the voltage while we're in constant current mode. Remember that. And you watch it, it's going to jump. We saw those little spikes. Now we'll zoom in and we'll capture those spikes. No, it just went out there. There we go. Bingo, captured. It lasts for like, 12 milliseconds or something like that. And it's jumped out of constant current mode when we adjust the voltage. That's very interesting. Why is it doing that? Oh, it's not a consistent time. That's a bit nasty, isn't it? Wow. Yeah, it shouldn't jump out of constant current mode when you adjust the voltage like that. I think we have a glitch. Anyway, this isn't going to be a review. There's going to be, this has a whole bunch of stuff. As I said, it's got the arbitrary waveform stuff. It does the easy ramp, which is, I think I've had a look at that in previous videos on the previous model, haven't I? But yeah, of course, you can turn on remote sensing here. Channel fusion. I assume that's parallel and series because that's hilarious. Channel fusion. Connection mode. Yeah, that'll be series parallel, surely. Oh, and can we... Oh yeah, series parallel. Channel fusion. I love it. Germans. I'm sure if you want to look into this, there's a whole bunch of stuff that you can play around with. Ethernet, the wireless LANs, the digital I/O and stuff like that. What can we do with our digital I/O? It's just trigger, I believe. I don't think it's output on condition, output on. See, there you go. So when it receives a digital input trigger on channel 1 or whatever, you can, make it do stuff. You can make it, I don't know, can you condition like that? Let's have a look. What options do we have? Output on, output off, fuse trip. There you go. Constant current mode, voltage level. There you go. Say critical event. Easy arb active, so you can turn on your arbitrary mode. I was hoping it would do that. So yeah, that's pretty flexible stuff. Utilities, system test, update, service, all that sort of jazz. Anyway, there you go. That is very cool. That's like the current resolution on this thing. Absolutely amazing. I can't remember the specs on the current. Hang on. It's actually 0.03% of the current, which sounds impressive, but it's got a little plus 500 microamps next to it. So the low current stuff, absolute accuracy. You get the resolution, of course, which is down to 1 microamps. Accuracy, not necessarily there, but still, to get that sort of resolution on a basic series power supply like this is really quite incredible. So 0 to 100 volts, very versatile. Go up to 200 volts in series with that sort of current resolution. Very versatile supply. Or you can get the 102 version, which is the your more traditional 35 volt model. Anyway, if you want me to do any specific tests on this, I can, and just dump it on my EEVblog 2 channel. About to hit 100,000 subscribers on there, so definitely go check out and subscribe to EEVblog 2 and set the bell notification, all that sort of wanky business. And as I said, I've got 2 of these bad boys to give away. One is the 104 model you see here, the 100 volts. One is the 102 model, the 35 volt 6 amp jobby. So what I'm going to do, because the YouTube comment system is always a shit show. I'm just like, no. I'm going to create threads over on the EEVblog forum, and one of them will be a random draw. So I'll link to a EEVblog thread down below. Check it out. You have to be a an existing EEVblog forum user. You can't just join now and do one post and, enter. Sorry, but, it's for those who contribute to the site. I think that's fair enough. And I'll also give one away to a hackerspace, makerspace school, something like that. So that will be judged by me. So I'll have a separate thread for that. Put in your, submit a video entry or whatever. Submit, I don't know, just, yeah, we're a hackerspace and we need one of these things. And I don't know, I'll choose a worthy winner. So thank you very much, Rohde and Schwarz, for providing these to give away to my audience. That's fantastic. And an interesting look inside a completely linear supply this time, instead of the combined track-in, switch-in pre-regulator, which you get in this. But of course, you get advantages in that it is more powerful. It's got triple channel, of course, more total output power. It's smaller form factor, all that sort of jazz. But yeah, if you want a nicer, cleaner, linear supply like this, then check it out. Linked down below. So if you like the video, give it a big thumbs up. As always, discuss down below. Catch you next time.